IB Physics, May 2025, Time Zone 2, SL Paper 1A, question 18. So what is the unit for the permeability of free space times the permittivity of free space expressed in fundamental SI units? Well, I think the easiest way to solve this question is if you know that c, where c is the speed of light, is equal to 1 divided by the square root of the permeability of free space times the permittivity of free space. Because if you know that, then you can rearrange it to say that mu naught times epsilon naught is equal to 1 divided by c squared. And from that, you can set up an equation of units, right? We have 1 divided by c squared, and the unit for c, the unit for the speed of the light, is meters per second. So that'll lead you to the units that are in answer choice A. So answer choice A is correct. But what happens if you don't know that speed of light equation? Well, then you can look in the data booklet. And in the constant part, you will be provided with the units for the permeability and for the permittivity, right? This here is a screenshot from the data booklet. Now, with these units, you might think, well, then we just have to multiply them, and then we'll get the answer. But that's not quite true, because the question is asking for the fundamental SI units, and a Tesla is not a fundamental SI unit. So that means that answer choice B and answer choice D are incorrect. A coulomb is also not a fundamental SI unit, and neither is a Newton. So we need some way to put these units into fundamental SI units. And let's look at the permittivity first, right, for epsilon naught. Well, what is a formula that we can use here? We can use the electric field force between two charged particles, right? Because that is equal to 1 divided by, and this is in the data booklet, 4 pi times epsilon naught. And then that times Q1 times Q2 divided by r squared. And since we're trying to find the units, let's solve for epsilon naught. Epsilon naught will be equal to 1 divided by F times Q squared divided by R squared. And notice that I made some changes. First, I got rid of the 4 pi, and then I assumed that Q1 was equal to Q2, so then we can write it as Q2, because the numbers aren't really going to matter when we're trying to find the units. The units are all going to be the same, and the constants aren't going to affect the units. So this is what we have here. And if we can write this as an equation of units, then we're halfway there. So let's do that. In units, well, the unit for a charge is a coulomb. So we have c squared, and then the unit for a force is a Newton. So we have n, and then for r squared, that'll be m squared. So this is what we have now. But again, a coulomb and a Newton, neither of those are fundamental SI units. So how do we write a coulomb in fundamental SI units? Well, a coulomb is equal to an ampersecond. So that means if we substitute it in, we will have A times S squared divided by N times M squared. And I'm going to leave the Newton as it is for now. We could convert it to SI units, and the way you would do that is, well, we can just say F is equal to MA, and so the unit for force is a Newton, the unit for a mass is a kilogram, the unit for acceleration is meters per second squared, and then you substitute this in. But I'm not going to do that, and for reasons that you'll see in a second here. What I am going to do is just simplify this a bit and say that this is equal to A squared times S squared divided by N times M squared. So that's the unit, those are the units for the permittivity of free space. But now I want to look at the permeability of free space and those units. So we have a Tesla times m times ampere to the -1. So the only unit here that is not a fundamental SI unit is the Tesla. So what is a formula that we can use that will get that Tesla into fundamental SI units? Well, so a formula that includes the unit Tesla, and that is the magnetic force formula. That's one of the formulas we can use. So let's do that. That says that F, and F is the magnetic force on moving charged particle, is equal to B. B is the magnetic field strength, and that is the one that is measured in Teslas. And then times QV, right? The charge times velocity of the particles. So if we solve for B here, right, we get F divided by QV. And again, I did that because I can write an equation of units. A Tesla is equal to the equation, the unit for force, which is a Newton, divided by the unit for a Coulomb, which, the unit for a charge, which is a Coulomb. I'm getting ahead of myself. Then, of course, velocity is meters per second. So let's use the same substitution from earlier, that C is equal to an amp per second. And then we will have N divided by A times S times M divided by S. So that'll be equal to N divided by A times M. And then we can take this T and plug it back into our original units from the permeability. And if we do that, we will have N divided by AM times M times A to the -1. So notice that the M's here will cancel. We will be left with N divided by A squared. And those are the units for the permeability, right? And the question is asking the unit expressed in fundamental SI units when we multiply these two. So all we have to do is multiply the units. So at this point, we have these two units. So let's multiply them. Notice that, well, let me just rewrite this here. So we have A squared times S squared divided by N times M squared. And then that is being multiplied by N divided by A squared. So notice that the newtons will cancel, which is why I was saying we don't have to make this substitution. So the newtons cancel, and the amperes will cancel, leaving us with S squared divided by M squared, which you can also write as answer choice A. So that verifies our answer as answer choice A. And there we go.